Hello guys, welcome to my channel. So as you know, we are studying about the carbohydrates. And in the carbohydrate we are studying about the monosaccharides. All right, so further moving in the topic. So now we'll see about the blood glucose as we are studying about the carbohydrates and the monosaccharide. So glucose measurement in the diagnosis and treatment of diabetes is really important as glucose is the principal fuel for the brain, as we all know. When the amount of glucose reaching the brain is too low, the consequences can be dire. It can lead to lethargy, coma, permanent brain damage, and death. So, the complex hormonal mechanism have evolved to ensure that the concentration of glucose in the blood remains high enough to satisfy the brain's need, but not too high because elevated blood glucose can also have a serious physiological consequences. Right, so the individual with insulin dependent diabetes mellitus do not produce sufficient insulin, correct? The hormone that normally serves to reduce the blood glucose concentration. That's the function of insulin. So if the diabetes is untreated, the blood glucose level may rise to several folds higher than the normal. So and this high glucose level are believed to be at least one cause of the severe long-term consequences of untreated diabetes, right? Like kidney failures, cardiovascular disease, blindness, and impaired wound healing. So, one goal of the diabetes mellitus therapy, what's that is to provide just enough insulin by injection to keep blood glucose level near normal, right? So to maintain the correct balance of exercise, diet, and insulin for the individual, the blood glucose concentration needs to be measured several times a day and the amount of insulin injected adjusted appropriately. So why the insulin is required several times a day? Because to maintain the correct balance of exercise, diet, and insulin for the individual. So the blood glucose concentration needs to be measured. That's the reason the blood glucose needs to be measured, right? So the concentration of glucose in blood and urine can be determined by a simple assay for reducing sugar, such as before it was like a Phalenx reaction. Uh, Phalenx reaction. Phalenx reaction, which for many years was used for many years as a diagnostic test for diabetes, right? Now in the modern measurements require just a drop of blood added to a test tube containing the enzyme glucose oxidase. So the test tube, what it contains is actually contains an enzyme glucose oxidase, the glucose. So the second enzyme of peroxidase catalyzes reaction of H2O2 that has been done when it's react with the glucose oxidase, so it gives H2O2 and glucone actually. And there is a second enzyme, a peroxidase, that catalyzes the reaction of H2O2 with a colorless compound to create a colored product, which is actually quantified with a simple photometer that reads out the blood glucose concentration. So the most important thing is because the blood glucose levels changes with the timing of meals and exercise, single time measurement do not reflect the average blood glucose over hours and days. So dangerous increases may go undetected, right? If you are doing just a blood glucose test just once in a day, it won't detect the average blood glucose of the entire day or like several hours, right? So if your blood glucose is increasing like in a specific daytime, so it will go undetected. So the average glucose concentration can be assessed by looking at its effect on hemoglobin. So what's the hemoglobin? That's the oxygen carrying protein in erythrocytes. So the transporters in the erythrocytes membrane equilibrate the intracellular and the plasma glucose concentration. So why we are doing the test for the hemoglobin by looking at looking the glucose effects on the hemoglobin? Why? Because erythrocytes membrane, because the erythrocyte membrane equilibrate the intracellular and the membrane equilibrate the cellular and plasma glucose concentration. That's the reason. right? So the transfer, so this were the transporters of erythrocytes. So the transporters in the erythrocytes, right? There are the transporters in the erythrocytes membrane that equilibrate the intracellular and the plasma glucose concentration. So hemoglobin is constantly exposed to the glucose at whatever concentration is present in the blood, and that's the reason hemoglobin is constantly exposed to the glucose at whatever concentration is present in the blood. So a non-enzymatic reaction occurs between the glucose and the primary amino group in the hemoglobin. That is either it's hemoglobin is a protein, right? As we know, and we studied in the protein. So what exactly in the protein? It might be like an amino terminal valine or and allison amino groups of lysine residue. So that it reacts with the non-enzymatic reaction occurs between the glucose and the primary amino groups of the hemoglobin. So the rate of this process is proportional to the concentration of glucose. So how? So the rate of this process is proportional to the concentration of glucose. So the reaction can be used to estimate the average blood glucose level over weeks. So the amount of glycated hemoglobin, that is GHB, hemoglobin, that is GHB present at any time reflects the average blood glucose concentration over the circulating lifetime of the erythrocytes. And what's the lifetime of the erythrocyte? Time, as we know, that is 120 days, correct? So this will, right, so the amount of this glycated hemoglobin that comes in the constantly contact with the glucose present at any time reflects the blood glucose concentration over the circulating lifetime of the erythrocyte, that is about 120 days. Although the concentration in 2 weeks before the test is most important in setting the level of GHB. To the extent of hemoglobin glycation, so named to distinguish it from the glycosylation, the enzymatic transfer of glucose to a protein, right? So there is a difference between, okay, we'll write down the entire name, glycation, right? And there is a difference between glycosylation. It's not hemoglobin glycosylation, it's glycation, right? So this glycosylation is the enzymatic transfer of glucose to a protein, right? So the extent of this hemoglobin glycation is measured clinically by extracting hemoglobin from a sample of blood and separating the glycated hemoglobin GHB from an unmodified hemoglobin electrophoretically. This is how it is separated, and then taking advantage of the charge differences resulting from the modification of the amino group. Right, so the normal values of monoglycated hemoglobin referred to as an HbA1c. Right, so what it is referred to? Monocytic hemoglobin. So the test is referred to as HbA1c, correct? HbA1c. So these normal values of the monoglycated hemoglobin or HbA1c are about 5% of the total hemoglobin, corresponding to a blood glucose level of 120 mg per 100 ml. So it should be like 20 per 100 ml. Right? The blood glucose level should be like this. So in people with untreated diabetes, however, this value may be as high as 13%. So this is about 5%, right? But if the diabetes is untreated, the glucose concentration may be as high as 13%, indicating an average blood glucose level of, so if it's 13%, so it may be about like 300 mg per 100 ml. Correct? That is dangerously high. And one criterion for success in an individual program of insulin therapy, the timing, frequency, and amount of insulin injected is maintaining HbA1C values at about 7%. So this should be maintained if the person is diabetic, and the insulin therapy program, for the timing, frequency, and the amount of insulin injected, that should maintain the HbA1C at 7%. Not exactly 5%, this is for normal, but at least at the 7% value. Right? Right, so we'll see. Some space. Okay, I think that might be enough. Okay, so okay, right, so this is glucose and this is step 1. Right, so first the glucose comes into contact with hemoglobin, correct? So plus 2, and then that is R. Okay, so this is, okay, I'll write it down, hemoglobin. All right, so in the non-enzymatic reaction of the glucose and the with the primary amino group of the hemoglobin, just a primary amino group of the hemoglobins begins with the formation. So what it will formate first. So this is the, for example, the normal process. So the first will be it will formate a skiff base. Right, so this will formate a skiff base. Right, so first the reaction with the non-enzymatic reaction with the glucose and the hemoglobin, the first step will format a skiff base. And what is a skiff base? So it's just a skiff base is named after a Yugo skiff. It's just a compound with a general structure. That's the general structure R1, R2, then the C equal to this and R. Right, so this is just a name of the compound named after a Yugo skiff. So that's a skiff base. And afterward, this skiff base goes immediately to make a general stable structure. So I will show you the stable structure. So this will be like this. So first it will go like this, and then to B, for example, CS. That's still the OH, correct? and then here it will be CH2 and HR. That will. And this product is ketamine. So this product is ketamine, right? So when glucose comes into contact with hemoglobin, it will form a skiff base, and the skiff base will go to generate a stable product, and this is the final stable product, ketoamine, right? This is will arrange like this, and this will goes to arrange with the ketoamine. And this ketoamine goes further cyclized to become the glycated hemoglobin, right? So in the third step, this will become a glycated hemoglobin. And this product is glycated hemoglobin, that is GHB. So glucose comes into contact with hemoglobin, it first forms the skiff base, and then it generates a stable product. This goes first like this, then this ketoamine as a stable product, and then this ketoamine is cyclized to create the glycated hemoglobin. Right? Then the subsequent reaction can generate an advanced glycation end products, or like an hemoglobin glycation reaction. As we saw, the first step is the skiff base and is followed by a series of rearrangements like this, oxidation and dehydration of the carbohydrate moiety to produce the heterogeneous mixture of AGEs, that is an advanced glycation end products, right? And this glycated can result in AGEs, that's advanced glycation and products, right? So this will result to an advanced glycation and products, and then it will be like protein cross linkage. This advanced glycation end products can leave the erythrocyte and form a protein cross linkage, form a covalent cross linkage between the proteins, interfering with the normal protein function. This can interfere with the normal protein function, right? So this is why the accumulation of relatively high concentration of this product ages in the people with diabetes may be cross-linking the critical proteins so this increases cross-linking of critical protein, causing damages to the kidneys, and this can damage to kidneys, heart, right, retinas, and that characterizes the disease. So this pathogenic process is potential target for the drug action, right? So the potential when the drugs are prescribed, so this is the potential target of drug action, right? And this AGES, advanced glycation and products, also act through the transmembrane receptors for the AGE or RAGES. AGE can stimulate AGE receptors when activate. So this AGE can, what it can do? Okay, we'll write it down. This AGE can activate AGE receptors as well, that is RAGE, that can be abbreviated as RAGE, and this stimulus downstream events including inflammation as well, and that's why there is an inflammation in diabetes. Correct? So this was the just a process. So hemoglobin, glucose, and hemoglobin comes into contact. That is from a Swift base, right? And then it produce generate a stable product, ketoamine, and that is ketoamine cyclic, right? Formation to the glycated hemoglobin, and then the glycated hemoglobin can be rearranged, and with the oxidation and dehydration it can go to the advanced glycation end products, and that advanced glycation end products can covalent cross links with the proteins that can result in damage to the kidneys, cardiovascular systems, and retinas. All right. And that's the why. That's the why in the diabetes, the potential target of drug action is the advanced glycation and products. Alright guys, so that was monosaccharide, specifically glucose, as that was really important for the diabetes. As we saw which tests are done and how it just goes and damages the kidneys or heart or cardiovascular system. Thank you guys for watching, and we'll see you in the next video.